So welcome to the first episode of Software Architecture on Stream in the new year. So happy new year to everyone. And our guest today is Patrick Kua. So Patrick, do you want to say a few words about yourself?
Sure, yeah. Hi, I'm Patrick Kua. I'm a seasoned technologist, having worked for almost 20 years. I've done everything from leading technical teams, software architecture, to being CTO and coach. These days, I'm doing a lot more independent coaching, mentoring for other technical leaders, helping their organizations scale, both people and technical-wise.
Excellent. And the reason why I was really looking forward to this discussion is because you wrote a book about evolutionary architecture together with Neil Ford and Rebecca Parsons. So what was your motivation for doing that? Why did you choose to write that book?
Yeah, it's a great question, and thank you for asking that. I think we started talking about evolutionary architecture sort of, 5 or 10 years after the Agile Manifesto came out. That was now 21 years ago. And I think one of the puzzles that a lot of teams had during those times was, how does architecture fit into Agile sort of ways of working and teams that are moving really rapidly? We kind of ended up on the term evolutionary architecture, even though we were debating about topics like, agile architecture or continuous architecture. But there were specific reasons we didn't go to that, even though something like continuous delivery has become very popular. And I think the evolutionary metaphor works quite well because, firstly, architecture isn't continuous, is that we sort of make leaps and boundaries on architecture. So, if we stop coding on systems, the architecture is not continuous, but we do need it to evolve. And I think the evolutionary architecture sort of concept made a lot more sense because sometimes architectures need to change, not necessarily based on the tools or the system that people are using, but also in response to the environment, right? So, things like today's world of a lot more connected platforms that are using maybe APIs from other sort of services, that's quite different and wasn't available, say, 10 years ago, or maybe 20 years ago, or less common. And often things that other platforms enable also mean that business models change. So our software also has to respond to that. So, I think from a commercial perspective, we maybe all used to buy records or even CDs, cassettes back in the day. But, today most people have some sort of streaming service. And so, that fundamentally changes also the types of systems and the architecture we need in order to support things, not just pricing and subscription, but also things like licensing and attribution. So sometimes evolutionary systems need to change, not just because we want them to change, but also because they have to change based on the environment. And so that evolutionary sort of architecture mindset for us really captures this idea of we have to build systems that are ready for change, not just because we want to make changes to them, but because sometimes we have to.
Okay, and I think you touched an interesting point there. So we have a very changing landscape, and things are changing a lot. Like you said, the way that music is distributed, for example. So if I want to have an architecture that is able to cope with that change, I need to predict that, right? So how am I going to do that?
Yeah, and I think this is where the evolutionary mindset makes a lot of sense as well, because, I think with evolution, there's nothing really which is about sort of predictive evolution, right? So you can kind of think about this as we want to plan for the perfect situation. And if we take that evolutionary mindset, that really helps us understand that what we need to do is draw upon techniques and practices that allow us to adapt and keep supple. And so this is part of the challenge for us as software architects is that, we need to be able to sort of look forward, but I think that's a little bit different from predicting. And so I think this is a big change is that, when we think about architecture, often we're thinking about predicting a single outcome over a fairly long horizon. And the approach with evolutionary architecture is thinking about, okay, what can we do to perhaps keep as many options open, knowing that we still have to make some decisions, but we want to sort of cater to change and be ready to pivot as much as we can. Of course, you can take that maybe too far, and you can add perhaps too much unnecessary complexity to, having this wonderful service that could do everything. And this is one of the other things that we touch upon in the book, is that, if you go down that path of trying to make a system too changeable or too flexible, you sort of also lose its functionality or its purpose. So you can make a system too complex by allowing it to be pluggable, to be changeable, but then it's often also at the cost of you actually not delivering value, which is part of the idea, is that a evolutionary architecture also needs to be fit for the current world and the current circumstance. So for a lot of the systems that we build, they're often commercial systems. So, they have to actually be delivering value. Often that means they have to be solving problems for customers, or you have to be sort of adding in and evolving the feature set to make it more appealing to customers. And probably, last year is a really good example where a lot of businesses had to pivot to a lot more of a online distributed model, right? So with COVID, people working from home, that change in the landscape means that actually the systems have to sort of adapt. It was probably unlikely we could have predicted when something like that was going to happen. There was always talk about, what happens with a global pandemic, but there was no way that anyone could have really predicted when that was actually going to happen and how that was going to impact. But those organizations that had really invested in evolutionary architectures, they're in a best place to be able to pivot, to be able to adapt to that, right? Accept that the landscape has changed, accept that the changes in business priority, but also know how to perhaps make their systems adapt to that sort of environment. And so that's one of the dangers of, I think, predictive versus adaptive, is you do want to have some level of prediction, or you want to have some idea about looking ahead. So evolutionary architecture is not about sort of throwing out looking ahead. It's really about trying to maybe make sure that you're not committed to a single solution over too much of a long time span, and to try to keep as many options as open, but balance that against maybe adding too much complexity into your systems, which will sort of slow you down in the short term.
Okay, so you're using the term adaptability, first of all, so that seems to be a difference. And what you're saying in a way is that you should probably not invest too much effort into trying to predict the future, because you can't do that anyway, and therefore you should have a different approach.
Absolutely.
Excellent. So what I'm wondering is, sometimes people come to me and say, well, in this architecture, we already know that these are the points that are usually changed. And I'm always somewhat uncertain, because that sounds like we're predicting the future again. So what do you do about that when people tell you, well, these are the points that are going to change in the future, so we have to have a lot of flexibility around that? Is that something that you should be doing, or is that also not such a great idea as the prediction is?
Yeah, I think this is a challenge, because I'm going to give you the consultant answer, is that, it depends on what people are talking about in that sort of circumstance. If that company, or if your product has a history of saying, okay, we've had this change, and if you can base that on data, that becomes a lot easier. So as an example, right? So marketing has decided we're going to change the pricing of our product, this quarter. And then you have that sort of pricing change again the following quarter. It's a lot easier to sort of ground that, because it's not about predicting, but actually more about sort of extrapolating based on past data. But then there may be other situations, and this happens all the time in software architecture, where somebody has maybe been burnt in the past by something, hey, I want to make this thing configurable because in my last company, this is the thing that kept changing all the time, right? And so, that last company was a different circumstance, a different context, but you may not necessarily have that need in your current company or in your current product. And so you're sort of predicting based on your own personal history, but maybe not on the data of your current sort of situation. And so I like to sort of think about, a heuristic that I call about the rule of three, of, seeing if there's sort of 3 times of a sort of activity before you start to make something perhaps configurable or, adaptable for that. Of course, there's some good practices to be able to do that, right? So the sort of architecture pattern of sort of hexagonal architecture or ports and adapters is sometimes how it's called, is sort of, co-locating some externality onto one part of your system. So there's only one part of that point you need to change. You don't need to make that part super configurable yet and super pluggable, but you have now the option later of when you do have perhaps another instance of that to be able to have only one point of your system to actually make change. So this is a really good example of sort of thinking about making the future change easier, but not adding too much complexity in the meantime with the Uber types of configuration of how you might be able to sort of configure. And the more that you can base it on sort of the real changes that you've actually had to have and try to find the sort of the category or the class of change, then of course, then you should sort of make that next type of change a lot easier as well.
Okay, so that rule of three, that's actually quite a good idea, I think. So on YouTube, there is a question by Theorem Geek, and he says, well, how much upfront analysis is good enough to start the evolutionary architecture process? Is it okay to have just enough in order to implement the phase one, or need to have analysis until the final phase? Experience from phase one implementation could be useful when doing analysis for the remaining phases. I'm not actually sure what that means. So upfront analysis sounds like analysis that you do before you do anything concerning the implementation, and then probably a stepwise implementation I'm not sure about the phases. So maybe that's also, those are rather the phases that you have in that where you have architecture, design, and implementation, and so on. So I guess it boils down to the question, how much upfront analysis do you need before you do any real work, I guess, or before you do any implementation?
This is a real challenge. And I think it's interesting because, I worked in companies before Agile had got sort of really mainstream. And, back in the day, you would write your sort of architecture or your design specifications for a target product. And that would be maybe version 1. And the release cadence from like building that, analyzing it to actually releasing it was, between 12 to 18 months sometimes, for large complex projects. I think today, software is a lot easier to build, so you can iterate that a lot more. And so there's something that has to do with your sort of product release cadence, which will also have an impact as to how much sort of upfront design you can actually implement, right? So, if you can change your product on a daily basis, that's a really exciting place to be. You don't really need to be planning for a 6 to 12 month horizon of what changes you might have. But at the same time, it doesn't mean that you shouldn't do any sort of upfront thinking. So I kind of, it's hard to sort of quantify this because once again, it really depends on that sort of context. And the hard thing that we should always ask ourselves as software architects is sort of thinking about, what's the value versus the time investment around this, right? So, I think about the Pareto principle, which is the 80-20 rule. So how can we get the most amount of learning, perhaps, with the minimum amount of time, knowing that we're not going to get it perfect? So as an example, if you're starting a new company and a startup, you probably have an idea about the industry and the product that you want to build. So it doesn't mean that you go off and start, building your hacking your products. There's probably things like, what is the type of industry that you're in? Are there any particular special characteristics of that product aspect that you need to take into account that should shape your architecture? So as an example, I was CTO for N26, which is a bank based in Berlin. And obviously in banking, you need to think about regulation. And obviously you want to think about sort of reliability because you want to be safe as a sort of a financial sort of institute. And so the industry means, okay, those characteristics are things that you do need to think about fairly upfront. And so those things will be very important. And so it doesn't take a lot of effort to sort of sit down and think about, okay, what are the things that are important that I need to start building into the sort of architecture to do that? Now, of course, when you have a system and you're in a startup, you probably don't need to implement the heavyweight processes because you're not going to be catering to an audience of more than 100,000 people to begin with. You're probably going to start with 5 or 10 people to sort of prototype. But as the number of your sort of customers grow, obviously the severity of that changes over time. And that's one of the other things that we really wanted to encourage with evolutionary architecture, is that when you think about those things that are important, it's not a once-off activity that you do at the beginning of a product or a service. It's something you have to sort of think about fairly, I wouldn't say continually, but regularly, I would say, and at certain points in time. Right. So even your service might be doing really well. And Twitter is a really good example of this. In the early days of Twitter, the service didn't really change very much, but the number of people did. And so that meant that actually their service had to scale a lot more and failed to scale. I think everyone remembers the Twitter whale, or the fail whale, sometimes as people called it, when Twitter failed to sort of scale. And even though they weren't adding in significant functionality, just because of the sort of customer demand, the characteristic of scaling started to become a very important aspect. And so, it's not something that you can do to sort of reset, but actually you need to sort of be aware. And this is one of the difficulties, is that we can all fall into that sort of boiling frog syndrome where, we're building, incrementing, not realizing actually the environment around us has really changed. And actually it means that we as technologists have to perhaps persuade product and management people we have to reinvest in re-architecting or redesigning a significant part of our system, right? Because it was never designed to cope with the perhaps security or the regulatory changes or the scaling concerns as things have sort of changed around us. And so this is where, I think at a minimum, I would encourage teams to at least do a yearly sort of review of, how is their system performing? Is it suitable for the current plans for where your product direction is going? Some companies decide to expand into new markets, and new markets often mean either very different regulations or very different, particularly back office processes. Think about delivery fulfillment or taxation kind of things. There'll be different requirements per different sort of country based on that. And so you as a team can actually review, what have we thought about? Is there new characteristics that we do need to think about? And once again, if you can use data to actually use some extrapolation, then you can talk about, okay, maybe we've been onboarding users fairly regularly, and, we're now starting to see a fairly sort of accelerated trend of onboarding. Where are we going to be by the end of the year, and what can we do to actually deal with that?
Okay, so you're basically saying that you should do those reviews. And what I thought was interesting is that idea, that example of Twitter, because at the beginning, scalability was definitely not one of the issues that they were having, because there was that little user base. So if you try to do that upfront architecture, that will be very different from what you will have a few years later. So actually, there is no point in a way to invest a lot of time in the upfront architecture, because it will change anyways. So I thought that that was a good point.
Yeah, and I think that's another good example, is that I think if Twitter had invested in building a scalable architecture, it's hard to know, but they might have been so trapped in building this wonderful scalable thing that actually they never found product traction, right? So, it's a good problem to have if your system is sort of struggling to scale, because it means it's successful, but they may not have ever had that problem because they may not have ended up in a place where they were so successful.
Yeah, so I think that's a good point. And I have to admit, I'm not sure what you think about that concerning upfront design. I always have the impression that people are investing too much time in upfront design, and then they got stuck in we haven't thought about that, and this is also very complex, instead of trying to get something out there. Would you agree? Or because then one of the answers to the question would be, well, probably cut back, and probably you're trying to do too much.
Yeah, I think, before I was CTO at N26, I did a lot of consulting. And I think the behavior or attitude towards that is kind of driven by either the age or the type of company that they're in. So, Germany has a lot of engineering sort of firms with a thinking of, particularly embedded software, where you do need to think a little bit sort of more upfront, perhaps, because you won't be able to, update it on an hourly basis. You won't be able to release a new model in hardware. So there's a bit of a more upfront thinking, but I think those kind of maybe more purely digital or internet sort of startup type companies, what I observe is that they don't do enough of the sort of upfront thinking. Is it's just a bunch of people picking tools, assembling stuff, particularly in like serverless land where it's like, drag and drop, or, a lot more of this no code sort of talk where they could do maybe just a little bit more sort of thought around that. But I think you're right, is that when you start to go down this path of starting to think about all the possibilities, it's easy to fall into that trap of the what if this and what if that. And so this is where I encourage people to really sort of time box that activity, both time boxing, what you're targeting. So if you say we're targeting a time frame of, we're trying to build something knowing we want to end up with this thing in 3 years, but this is our sort of minimal viable product that we want to release in 1 year's time, that helps to nail down a lot more of the what if this, what if that scenario. So I think if you can end up with too much option and optionality, and I think people kind of panic with that. And so it's good to actually make decisions and assumptions that close down some options, at least from an educated perspective. So you've actually talked about them as well.
Okay, excellent. And I really did like that point that you were making about how different, let's say, cultures lead to different challenges, and I can relate to that. So that the startups would probably need more upfront design, while the traditional German engineering companies probably should cut back on it. So I think that was a good point. So we already spoke about some of the, let's say, practices, best practices, good practices that you can implement to make evolutionary architecture happening. So you were talking about those reviews, you were talking about time boxing decisions and time boxing your horizon that you're making decisions for. What are some other best practices that you could implement to get that more evolutionary approach going?
Yeah, so to maybe answer that, I think it's useful to come back to maybe a simple definition of what we meant by evolutionary architecture. And we talk about an evolutionary architecture containing 3 main elements. So one of them is that it supports sort of incremental change. So that means that you have to be able to release change, right? So if you theorize about what designs or you're optimizing for, you don't really test that out until you can actually get that into the hands of users. So a lot of the practices around continuous delivery are really about the basis and fundamental of building an evolutionary architecture. You need to have good continuous delivery hygiene, and you can do that even if you're doing embedded sort of software, is that it may look a little bit different and your horizons may be a bit longer than a purely digital product, but it means you should still implement them. The second element that we talk about was really about sort of guided change. And so this is where it's a little bit different. Rather than simply responding randomly to the environment, we do have a choice as software architects to decide on where we'd like to emphasize that change. And so what we encourage is thinking about fitness functions. So, fitness functions come from sort of the machine learning sort of landscape of, optimizing an algorithm to know what good looks like. And so, what we encourage people to do is when you're thinking about that sort of upfront sort of thinking, you're trying to identify what are the characteristics of what does good look like right now that you really want to optimize for. So, let's take a concrete example in banking again, right? Here we want to build secure software. We want to build reliable software. We want to build software that is idempotent in that, if you send money, you don't want to get charged twice for that money, right? Because that's very important. And so that's quite key. But, in something like advertising, perhaps idempotency is not as important, for instance, right? So, your role is there to sort of identify what are those key elements. And then the thing, if you can, is to think about what fitness functions you can implement that are perhaps a little bit more automated, or give that feedback to teams a lot earlier. So there's a lot of types of categories of fitness functions, or the quality of your architecture. And we categorize some of these within the book. But to give you an example of this, you might talk about, you want to build software that is easy to maintain, right? So this is important for systems that are strategic, but that may not necessarily be important for proof of concepts throwaway systems, right? So I wouldn't bother putting a fitness function into a prototype, but for the moneymaker part of your system, you do care about maintainability. And so, things like code coverage or cyclomatic complexity, you can measure those things, and you can put constraints into perhaps your build that creates an automated atomic unit that is sort of measuring one aspect of your sort of architecture. Netflix is a really great example of, thinking about, they wanted to build a system that was reliable. And so in order to do that, particularly at the scale that they're doing it, it's one of the reasons they sort of went down the path of sort of chaos engineering, or what we now call chaos engineering, of trying to poke and prod at their systems and to sort of randomly break things. And this is a really good example of, I think, an evolutionary practice in reality, because, when you have a complex distributed systems, you can't predict what are the error cases that are going to happen. But like in real life, our immune system, you kind of have to expose your immune system to sort of bouts of illness. No, not COVID right now, but flus or things like this. You can't just hide away forever, because your immune system gets stronger when it's exposed to small doses of these kind of elements, right? That's the idea behind immunization. And so, that's a really good example of the chaos engineering, is sort of by poking and prodding your sort of software, and it's not just your software, but it's also your processes and teams. Then your organization might have a bad day, but hopefully they also then put practices in place or change things that make the system a lot more resilient over time. And so that makes sense if your important aim for your system is resiliency, and not every system needs to be like that. But that's a really good example of a sort of continuous automated fitness function that we talk about, is that they're continually testing an important aspect of their architecture because it's important to them. And then the third element that we talked about with evolutionary architecture is it's the incremental guided change, but it also needs to be about multiple dimensions. So it's not just about, can we make technical changes as easy as we can? Can we swap out libraries and maybe overcomplex our application? But we also need to make sure that we can adapt the product and adapt to the business domain as well, right? And so that's the other aspect of it, is that we can't build wonderfully flexible pieces of software if it doesn't add value. So we need to also support change in a technical world of being able to keep our libraries up to date, to sort of evolve using modern technologies. But at the same time, we also have to be able to adapt our product to the needs of the business. And so that's the third element.
Okay, so one of the things that you mentioned is that with continuous delivery, you enable incremental change. Then you have that fitness function that basically says, okay, these are the important parts of the architecture, or the things that the architecture should provide. And you would do automated tests. You gave the example of chaos engineering and also code coverage for maintainability. But you were talking about N26, so that's a bank, and as you said, they were, with banking software, security, for example, is pretty important. So how would you do that? How would you make sure that there is a test in place that assures you that your software is actually secure? And would you cut back on the other tests for chaos engineering or code maintainability or whatever there is? And would you rather have more security tests then and less of the other tests?
So when we talk about fitness functions, not all fitness functions can be reduced to a single test. So it's one of the reasons in the book that we cataloged different types of fitness functions, but also different ways of approaching it. So as an example with security, there is no way that you can reduce it to a single automated test. But if you identify that your system or security, and I would say a lot of systems these days, security is a key concern, particularly as everything is all connected. The question is, if it's important for your system, so what types of fitness functions can you put into place as part of that? Now, because I don't represent N26, I can't talk about, all of the things that we put in place. But, when you're thinking about security, then it means that actually, okay, in this example, security is important. And you want to do as many things as you can to ensure that your system is going to be fit and secure as much as possible. And so with something like security, it's a very complex, multifaceted sort of area where, you might do things like how GitHub helps with vulnerability scanning, right? So prevent using dependencies or libraries that have known vulnerabilities. That's a very simple thing that you can do to put this into your automated process. But, often one of the challenges in software is as you're creating something, you're often not really thinking about how somebody might abuse your software that you design, because you've got a sort of building mentality, not a abuse mentality as you're building something. But taking that approach very early on in your sort of development process might help you prevent building things that might have been abusive, right? And so as an example, you might install threat modeling, which is this idea about thinking about how somebody might abuse your software or your design, into your development design process very early on. And so that it might actually stop you from building software or designing software differently that sort of prevents abuse from that perspective. And so that's an example of a fitness function that is sort of a process change that you can't really automate, right? So you can't, I've not yet found a way that people can sort of think about all the possible ways that you might abuse things, because humans are very clever at always finding ways and workarounds of abusing things. And so, you need to tap into that human intellect. And some organizations have what they call red teaming, right? So you have a red team, which is your attack team, who are very good at knowing how to break systems. And, often security teams are sort of involved quite late on by the time you've built everything. So a big change that you can have is actually by introducing and involving people who have that red team mindset very early on. And this is where sort of threat modeling and sort of workshops like that can actually add a lot of value to teams if that is an important aspect you want to build in.
Okay, so I think I like that point that you were making, that not everything should be a test or will be a test, but instead there might even be impacts on the process. So that's a good point, which also means that architects should probably care about the process and things, as you said, like threat modelings and so on, if you are looking for a secure software. There is a comment on YouTube by Gregor Tilch. He said, fitness function is a great way to delegate the design to teams in larger setup. When you reassess your context regularly, you can check your fitness function parameters again. I'm not sure whether you want to add anything to that. I think
I think it's a great point, because I think the role of the architect changes a lot more in this kind of new world. In the older world, architects used to sort of think about what is important and decide how you were going to sort of, meet that. And I think this is actually a little bit different, which is a subtlety that was picked up there, is that, architects, a lot of the value there is helping teams understand the constraints or what they should be optimizing their software for. And if you can automate and create visibility around that, so be it around, some automated test or metric, then teams have a lot more autonomy to be able to say, okay, so it doesn't really matter how we implement it, as long as we can maybe, hit these numbers or make this sort of contract. And so, an architect can add a lot more value by maybe adding in alternative ways, but they no longer need to then say, here is the single way you have to do it because I want it done that way. But actually, they can move on to other problems as well. So I think that's a nice subtlety that Gregor highlighted, is that by agreeing on that metric, if you can come up with a metric, not everything can, but if you can, then it does create a lot more freedom and autonomy for teams to be able to understand that they're building a system fit for their environment.
Yeah, that's a good one, and it's it reminds me about management by objectives, where you are basically saying, okay, this is the objective, and I don't really care how you make it, but that's what where you should be, and which gives more allows for more creativity. So that's a good point. Then Theorem Geek, also on YouTube, asked a question, and he or she said, is there a standard way of measuring fitness functions of a desired architecture? I assume this is used to answer the question, are we there yet? Do people do people calculate the total number of tests that pass, or is there a weighted approach to this?
So I haven't found so we often talk about like, you have your overall fitness function, which is actually composed of all your different fitness functions that you choose for your system. And there is no one single thing that encompasses that. So what's important, I think, and this is the pragmatic side that we want people to come away with, is don't worry too much about like a number or the single thing. What's more important is that you think about those characteristics you're trying to optimize a system for, and see if you can use ideas to find ways to put them into your sort of process and automate them, or to make them objective as much as possible. Nothing will ever be completely objective, or you can't boil everything down to a single number, so you can't necessarily do that. But there are some good examples that I've seen over time. So at least in the Java world, there's a really good tool called Arch Unit, which is like the unit testing framework for your architecture, right? So now it can't tell you if you're building the right software for your product, right? For your market, but actually it can help you measure certain aspects of your sort of architecture around that. And, tools like Sonar have done a lot in actually expanding, and, their pluggable nature allows you to sort of put things in. But what these tools won't necessarily do is tell you what is important for your system. And so that's why your role, the sort of qualitative assessment of what is important for our system right now for the product that we're building, you still need to make those choices.
Yeah, and also I think I'm not sure whether you would agree, but it seems to me from what you say that the fitness function is not something that gives like a number where it says this is 42% fit or something, but it's rather an idea. And in some cases, like the example that you gave with threat modeling and security, well, you can't know how many security holes there are still in your system, can you? So it's hard to quantify that, and for that reason, probably that part of the fitness function that might be very, very important is something that you can't really measure at all.
Absolutely, yeah. So it is the idea rather than here is the universal formula that you can pump everything into. But if somebody does find that out, drop me an email.
Yeah. However, what you could actually do is you could try to measure the number of security holes that have been discovered, but that's post-mortem, and that doesn't really help you a lot, I guess. So when you were talking about the basics of evolutionary architecture, you were also talking about the multiple dimensions and how you would support business changes. To me, that's one of the fundamental aspects of architecture, I would say, because at the end of the day, there is that business case that you need to support. So how do you tackle that problem? I think with the fitness function and with incremental change, that's, I guess, somewhat obvious. But what are some techniques to make to deal with that, with those multiple dimensions?
So the reason we talked about this, and I think you make the assumption that all architects take architecture with a business value added approach. That's not been my experience, because some architects I find get caught up in making the system so flexible or configurable that they sometimes don't necessarily think about, what is the value for software architecture, or how does this support the change that our business needs today? And so that's one of the things that we did want to bring in, which is, what good software architecture should look like is what you described, is that it should support the changes that the business need to have, over the sort of next horizon. And there's always a sort of small tension there, because you can always get into that place where, people don't invest in architecture because they're trying to make changes for the business. But because they haven't invested in architecture, it becomes harder over time to make changes that the business needs as such. So I think what I have found useful over time is when you go through a sort of architectural review or a, sort of early phase inception around thinking about, your architecture, it's useful to, when you identify those important characteristics, to involve business people. So often a lot of people think, software architecture, that should just be for the technical people. But actually, I think this is where you start to deviate and you start to design things that aren't actually going to be fit for the business because you haven't involved people from, marketing or product and saying, here's what we're trying to optimize for. What's your sense of this? Does this make sense, right? So I can think of an example where, I worked with one team and, they did a showcase after a early inception saying, okay, here's what we're trying to build. Here's the things that we're trying to design our system for. And one of the things that they'd sort of designed their system for was sort of flexible sort of pricing and sort of product expansion because they expected, based on the discussions, for the company to go into different types of markets or to offer different types of products. And, when they ran this with the sort of product people, the head of product at the time, they came back and said, hey, why are you adding in that complexity? I don't really understand. We're not going to build new products, at least not in the next year. And we're not planning on launching into a new market in the next year. So, that feels like you're investing a lot of time. And what's often very helpful is if you can actually quantify the effort around building that, right? So either it's around the stories or the time invested in building that sort of extra functionality, you might then choose, okay, is this an option or what do we do to create an option so that we can defer this, right? So you obviously don't try to add in extra complexity, but also you might say, okay, what can we do such that we might, if we want to do that in the future, make that a little bit easier without adding extra complexity as well. And so that's an example that I think if you involve business people in your sort of planning process, in your architecture reviews, and particularly if you come to a point where you have architecture work that you need to invest in, you have to be prepared to better describe what business value or problem that architecture work is solving, and in a way that the business can understand. So either about reduced costs, about enabling an opportunity, and it needs to map to sort of the product roadmap as well. And so there are a couple of the elements that we wanted to make sure come across in that book, because we've seen from experience too much that software architects are often spending a lot of time with technical teams and not enough with business people, or at least not sort of aligning with business planning.
Okay, so that of course makes a lot of sense. What I'm wondering is, why are you calling that multiple dimensions? I mean, what you're describing sounds to me like business alignment, something like that. Why do you call it multiple dimensions?
So catering to business change is one dimension, but the other change is really the technical domain, right? So this is really about keeping up to date with libraries. So the typical thing that every developer or architect thinks about is, what happens if this service goes down? We need to plug in an alternative gateway or a potential service, or how do we upgrade our libraries? How do we upgrade our framework? So it needs to support both of those elements, right? It needs to support your business changes, but it also needs to support technical changes as your ecosystem of tools also change over time.
Okay, I see. Theorem Geek asked the question, is architecture never done? I'm not sure whether that's a comment or a question. So what do you think?
Yeah, I mean, I think this is the interesting thing in today's world. It still depends on your product. So, if your product is working fine, you probably don't need to touch it, right? So maybe the architecture is fit enough for that landscape. And so I think this is one of the challenges, is we can't predict how long software is going to live, right? So some tools, right? If you think about our Unix tools, sort of like ls or man, those things probably haven't needed to change for a very long time. You might argue that they could, but they're fit for purpose, so they don't need to change as such. But we can't really predict how software and products are going to change. So if your product is never done, then theoretically your architecture is never done.
Yeah, that was actually a good point with the Unix commands, because I would actually I would have said that architecture is really never done, because I you know, at least when I go to some projects, it's usually that there are some gaps and that you need to improve it. But
and I would say on that, it's probably because you're brought in because people want changes, and there is sometimes no need for change.
Oh yeah, so that's probably another good one. Then Axel Hecht said one thing Firefox measures around security, so we had that discussion about how you can measure security, is the time to ship a fix. And Felix Müller said, well, this sounds like mean time to repair from the Accelerate book. And I would agree, that sounds like the incremental change that we were talking about and the continuous delivery, which I guess gives a lot more benefits than just security, right?
Yeah, absolutely. So this is one of the reasons we didn't want to say, you know, all the practices that from continuous delivery. Maybe put another way, you can do continuous delivery without having an evolvable architecture. But if you really want to be able to evolve your architecture, you need a good sort of basis of continuous delivery to do that. So as an example, you know, with that security sort of fix, it's wonderful that you can identify those problems, but if you can't actually ship them, then you're not actually benefiting from it as well. So they're sort of related, but we like to think about evolutionary architecture as a sort of broader concept than just continuous delivery.
Okay, I see. So let's change the topic. So in your book, there's actually a whole chapter about data. And, you know, data is not software, data is data. So why is that important for evolutionary architecture? And also, you were actually talking about two-phase commit. So that's, you know, that's just a technology for doing distributed transactions. How's that related to evolutionary architecture?
So, you know, I think one of the things that we often think about is we describe ourselves as software architects, but software doesn't live in a bubble. And so when you think about software, for software to work, it needs to work with other things like people, organizations, and data. And so that's one of the reasons why we wanted to put data into that book is, you know, particularly in today's age of systems generating a lot of data, but also there are downstream systems that depend on that are sort of inherently coupled, but maybe not as obviously coupled to the software that you're actually building. Right. And so that's one of the things that we really wanted to emphasize in there is particularly in today's age of systems and, you know, use of data, you know, we want to also think about how do you build software systems that you can evolve them, but be aware that there are other systems that might be ingesting data produced by your system, or your system might be ingesting data from other systems as such. And so because data has played such a big topic in sort of in today's world, you know, big data, all of that sort of lovely buzzwords, we wanted to really add in some general approaches to how you might think about that with building evolvable systems. And so maybe this is a slight difference between the idea of systems versus software, where I see software only being a part of a system, where the system is the broader ecosystem of the people who operate the software, the hardware or the virtual hardware infrastructure, and the data that makes that system useful. And so if you're really building an evolvable software system, you need to also be thinking about the other elements that plug into that sort of broader system. So that's one of the reasons why we contributed like a whole section around data around that, is to make sure that people should not just focus on the software, but also understand other sort of parts of that system that will be impacted. And you probably need to sort of either protect your system if you're ingesting data from systems, because, you know, this happens to everyone, right? Suddenly you've been relying on a data feed for a long time and it changes, right? So how do you make sure that you have that? Whereas if you're generating that data ingested by other systems, then you always need to also be conscious about, you know, what you do around schemas or, you know, changing, maybe you're not even changing the data schema, but how you use that data. So the field might still be there, but maybe you're implying something else by that. And so that's some of the topics that we sort of want to cover in there. I think in terms of answering the question about the sort of two-phase commit, in the UK where I did a lot of consulting, I worked for a lot of banks there, and I think the two-phase commit is an interesting sort of approach. And this is something that I think it was probably Neil that was a lot more strong. He wanted to put something into the book to sort of talk about two-phase commit specifically, because it can be something. It is a technique that we can use, but it also impacts evolvability. And often people use this as a mechanism of saying, okay, well, we want to do this because we care about transactionality. And it's easy to do because we have that available to us. But what they don't realize is that they're making that trade-off between that and perhaps the changeability, again, of your sort of system, right? So be it locked into whatever two-phase commit approach that you're using or the specific proprietary maybe database or sort of service sort of framework that you're actually using. And so we wanted to make sure that people understood that there is going to be a trade-off if you go down that approach, is that you might make your systems a lot more difficult to change if you go down that approach.
Okay, so that's an interesting point. I think, and one of the reasons why I was asking that is because I actually did an episode not too long ago about how two-phase commit is well, let's say a challenge. And it seems there are still quite a few people who think that, well, you need to have two-phase commit for proper secure systems.
I don't know if you raised this that episode, but Gregor Hope has a really excellent article about Starbucks doesn't use two-phase commit, right? It's a really good analogy.
Yeah, that's actually a good point. I was sort of making similar points, but that's a very good point about how in real life you don't really have that. So Theorem Geek actually asked a very good question, I think. Just on YouTube. So, talking about Gregor. So Gregor Tilch also talked about the architecture elevator. That's one of the ideas. Gregor is talking about how you should be able to talk about your architecture on different, let's say, levels. But it is probably not something that we should dive too deeply into, even though you did write a book about how to talk to tech leads. So probably you do have an opinion about that. I would rather talk about the question that Theorem Geek was just asking, and he or she said, any tips to avoid massive rewrites or the risk of when evolving the architecture? Sometimes upfront decisions implementation could be costly to change. And in the preparation, I was actually, I came up with the question. If you look at Martin Fowler, he says that architecture are the decisions that are hard to change. So building an evolutionary architecture in a way is an oxymoron. So how do you deal with that? How do you deal with the fact that architectural decisions by design are hard to change? And how do you avoid those rewrites?
So I don't think you can avoid rewrites, to be honest, right? So at some point, sometimes your landscape will change so drastically that the original system that you built will no longer be fit for purpose. So when I think about change, Lean talks about Kaizen and Kaikaku. So Kaizen being the incremental improvements that you make. But sometimes there is a need for Kaikaku, which is drastic change, like rigorous, complete change. And so I think this is the thing is that, yes, architecture is about, the things that are difficult to change or costly to change. But we go back to that idea is that sometimes you won't be able to predict the cost to be able to change that because you don't understand or you can't predict how that landscape will change over time as such. And so this is where, if you're doing too much sort of upfront or adding in too much complexity early on, you may end up in that situation where you're building a system that is not successful, right? And so you probably don't understand, you might feel that you've built a system that is fit for change, but actually you might not have actually have had the system that you could have had or the successful product you could have had because you were investing so much time in making a flexible, wonderfully precise sort of system. And so I think that's the sort of trap there is that we can pretend that we can predict all of the costs of change. But Of course, we said, it doesn't mean that you should throw out all thinking. It comes back to that sort of Pareto principle, the 80-20 rule, is that it makes sense to sort of sit down and, we can be a lot more certain about the things that are closer to us, right? So we can be more certain about the things that are going to happen next week. We can have some better certainty probably in the next 3 months than, say, the next year. And so you can use that to educate, have discussions with your team and agree on what change you're trying to optimize for. And I think one of the best sort of tools or processes that people are using these days is by making sure that you write these things down. So Michael Nygaard talks about this sort of architecture decision record about, why did you make this certain choice at the time that you had, right? So we might look back over 20 years and sort of laugh at people about building systems around that sort of time, but they had a very fundamentally different tool set. The types of products being built were very, very different. And sometimes we don't appreciate how, we're working in a very different world today with, APIs, cloud-based systems compared to say 20 years ago. And of course, we would make different decisions based on that. But if we don't have that sort of history of why we made decisions and what we were optimizing for, obviously people will fill in the blanks with often thinking about the worst. And so I think it's very helpful to sort of write things down, to use that sort of time horizon to sort of think about, what are the things that we care about, and maybe not to worry about the things that are going to be in 3, 5, 10 years time. And make sure that we have discussions with people to make sure we're making shared assumptions as well.
Yeah, and probably also assume that people actually made the sort of best decisions that they could possibly make at the point. And so I like your point that you're saying, well, you can't avoid rewrites. And maybe it takes some courage to acknowledge that at one point you need to rewrite. So Felix Müller on the chat just made, I think, a quite good point. So he said, a good architecture is made for constraints and environment at hand. If this changes, architecture needs to adapt. And you cannot predict this. So better focus on improving teams and decision making. So that's I think that's an interesting point, because basically what he's saying is maybe you should optimize the teams and the decision making, and there is just so much that you can do if you limit yourself to architecture, I guess.
Absolutely.
Right. And the Theory Geek just made a note for revisiting later concerning architecture decision records. So maybe, do you want to say a few words about that, how they actually work and how you fill them in and these kinds of things?
Yeah, so I like to separate two different things. So one which is the process of coming up to a decision. And so sometimes you might have a design document, or you might have like a RFC, request for comment document, where that document should also be talking about, the options that you explored, the pros and cons, what you actually did. But at the end of that, you make a decision. And I think this is where it makes sense. So, I think if you have made a decision that's hard to change, it might be as simple as, we're going to use React, right? Or something like this, your base framework. That, if you choose a different framework, you have to rebuild a lot of things. An ADR can be as lightweight as a paragraph. That Price, he was one of the authors of the Growing Object-Oriented Software Guided by Tests book, very long book title. He has written a little command line tool that generates basically, I think it's a JSON file that you can check in into your sort of repository that sort of, you can sort of see the history of architecture decision records in that. But, basically, it's a paragraph approximately that you talk about, what is the decision that you made? Sometimes you might actually undo a decision or say, we've reversed on this, but there's a history of that, so you can go back. You talk about some of the reasoning why, and you make it accessible to the team. So, Nat made that sort of command line tool because a lot of the team is using their source control. Some people choose to put it onto a wiki as well. I mean, you'll have to agree with your team as to where's the best place to do that. But, I think it requires a bit of a habit, because often we are so focused on just creating things, we forget about recording and writing things down. And so that's a really key aspect of trying to make sure that there is an important aspect of saying, this is a decision doing, we want to also help our future selves, our future team members by capturing that, acknowledging it, and then leaving a bit of a trail behind.
Right. And I think the in my opinion, quite important points are, first of all, you should actually write it. And I guess the other point is that it's so very lightweight so that you actually do it and not just, pretend to be writing some documentation, because nobody likes to write documentation, I guess.
And encouraging new people to go back and look at the past decisions as well.
Yeah, that's also a good point. And you can put it in version control right next to the code. So that's also good. So we have been talking for an hour. So maybe a few things to add at the end. So you are doing a newsletter. Do you want to say a few words about that?
Yeah, so I run a weekly newsletter called Level Up. It's a newsletter for leaders in tech. It comes out every Sunday, and it covers things that are interesting for leadership topics, trends in tech, and things in orgs and processes. So it's supposed to help you save time. I do a lot of reading, and so I try to reduce what I think are the most relevant articles I've been reading.
Great. And on your website, there is a lot of other material. So there are some courses that you do, online courses, self-paced courses, and a lot of other stuff. I'm not sure whether you want to add some highlights there. We are definitely going to put a link to your website on the show notes.
Thank you. Yeah, so I'm running an online virtual workshop called Shortcut to Tech Leadership. So if you have team members that need help leveling up, or you are interested in leveling up, I run a monthly online workshop for that. And I'm also building out some course materials on the techlead.academy for leaders in tech. So currently there's a course on time management and a course on systems thinking as well.
Excellent. There is a question around that tool. I guess that was that JSON architecture decision record tool. So I think I will try to dig that out and put it in the show notes as well on the website. Anything else you want to add? Anything I forgot to ask you?
No, I think that's perfectly fine. I've really enjoyed the discussion so far.
Yeah, me too. So I think that was really worthwhile. So thanks a lot. Thanks a lot for doing that, and thanks a lot for all the questions and the comments. As I said, that's the first episode in English, and obviously it's great that the language barrier doesn't seem to be such a big issue. So thanks a lot, and have a great weekend, I guess.
Thank you, everyone.